Polar coordinates. Polar coordinates is very different than rectangular. Rectangular, we're used to using x comma y. We have the x-axis and the y-axis. Well, for polar coordinates, we have the pole, which we used to call the origin, and then we have the polar axes. Think of the polar axes as this positive x-axis. The best way to think about this is the North Pole. Looking down on the Earth, here's the North Pole, and then we have the concentric circles, for example, like the equator, Tropic of Cancer, Tropic of Capricorn. Okay? So before we had rectangular points, we would go over x and up y. Well, for polar coordinates, we have r and theta. We have a radius and the angle. Now typically when we did rectangular, we would go over first, so we would do the x number first and then the y. Well, when you do polar, the best way to think about it is do the angle first. Think about where the angle would be first. So in order to plot polar points, I first think about where's the angle. Once I find the angle, then I count out the r, how many radii I have. So find the angle, then count out how many radii you need, and then plot the point. So let's do some examples. First example is polar point 4, 11 pi over 6. So the first thing I'm going to do is I'm going to find the angle 11 pi over 6. Now this picture is a polar graph. This is a typical graph that you will see in a quiz or test. Notice that this polar graph is counted by 15 degrees. Normally, back when we did the unit circle, we counted by 30 degrees, and we only had 30, 45, and 60. So when you go to think of pi over 6, it's not this first line anymore. This is 15 degrees. Pi over 6 is going to be on this line, 30 degrees. So first step, find out where 11 pi over 6 is. Okay, so I know my unit circle, and I've decided that 11 pi over 6 is somewhere on this line right here. The next step is count out how many radii you need from the pole. So you have a radii of 4, radius of 4. So I need to count out 4 radii along that angle. 1, 2, 3, 4. So there's my ordered pair, my polar point 4, 11 pi over 6. Let's do another example. For this example, you have to go negative pi over 2. So just like as if we were on the unit circle and going in the negative direction to find an angle, you start at 0 and go to negative pi over 2. That's negative 90. That's right here. Negative pi over 2. Then from there, I go to the pole and I count out along that angle 2 radii. 1, 2. So then I plot my point. There's the polar point, 2, negative pi over 2. Here's the next example. Now we have a negative r. We have negative 3, pi over 4. We still do the same process. Find the angle pi over 4. So pi over 4 is along this angle right here. There's my pi over 4 angle. Then my next step would be I would count out 3 radii. Well, this negative indicates you go in the opposite direction of that exact angle. So this is pi over 4, but I don't want to go out 3 in this direction. It says negative 3, so that means I go in the exact opposite direction. 3. So my point is going to be in the exact opposite direction. 1, 2, 3, right there. So the negative r indicates go in the opposite direction as the angle that's indicated in the point. For this one, we want to go to negative 2 pi over 3 first. So find negative 2 pi over 3. So I found negative 2 pi over 3. It's this angle right here. So if I wanted to plot my point and it was a positive r, it would be somewhere on this line. If I had a positive r, it would be somewhere on this angle. But since this is a negative 2, that means we go in the exact opposite direction. That means it's going to be over here in this quadrant. So you start at the pole and go in the opposite direction 2 radii. So my point, negative 2 pi over 3, go to the pole, go in the negative, that means the opposite direction, 1, 2. So there's my ordered pair right there. Let's go back to example 3, because this same point has several other names. Actually, it has infinitely many names. But there are 4 that are very important between negative 2 pi and 2 pi. We were already given the negative-positive combination, so I don't need to worry about this point right here. We already have that one. Negative, positive. Can you think of a point that's in the same location, but is a positive angle and a positive radius? So to find the positive, we need to start at 0, get to the point, going in the positive direction. So I'm going to go this way. I know my reference angle is pi over 4. So what pi over 4 would this be? Once I know what pi over 4 this is, I count out positive 3 radii to get there. So my positive would be 5 pi over 4, which is right here, 1 more than 4 over 4, which is 5 pi over 4, and count out a positive 3. Now the negative. We do the angle first. Start going in the negative direction. We know it's something pi over 4, so what pi over 4 is this in the negative direction? If I went all the way to negative 180, that would be negative 4 over 4. Back up 1, negative 3 pi over 4. But we would do that if it was positive r. But we want a negative r. That means we want to go all the way over here. So what pi over 4 is all the way on the opposite side? Negative 7 pi over 4. Then say go in the opposite direction, negative 3. So here's the negative. And the positive negative would be just what we said before. Negative 3 pi over 4 and go out a positive 3. So there are the other possible names of this same point. So this point has really infinite possibility for answers, but there are 4 important ones. The positive, negative, positive, and negative, positive. This one was given to me, so I didn't have to worry about finding it, but I used it to help me find these other 3.